Hello and good afternoon, and welcome to this continuation in our video tutorial series on Linux containers. And specifically, we're taking a deep dive look at all of the different network virtualization that you can do with inside of a Linux container. And so the first series of videos we did dealt with the virtual Ethernet pair, and we took a look at a number of ways that you can set the virtual Ethernet pair up, how you can customize your settings, go with the default settings, and so forth. Now we're going to go ahead and tackle, as you can see here, it's very limited in terms of what it does, and this is some low-hanging fruit here, so we're going to knock this one out right now. And this is empty. And the empty network type, when we define our LXC, Linux Container Network Type, inside of the container config file, which you can find in var lib LXC, and then the name of the container, there's a file in there called config, this is going to create only the loopback interface. And so we'll talk real quickly about the use of the loopback interface, and you'll see typically the loopback interface is referred to as the local host, and we'll actually look at the etc hosts file on our Linux host here. So we've got etc hosts, and it typically shows up as 127.0.0.1. Now you'll remember from our conversation yesterday when we talked about DNS mask, we saw that DNS mask actually used 127.0.1.1. And so typically, and we'll see what our host file shows, you're going to see 127.0.0.1. Now the range of addresses for the loopback address goes from 127.0.0/8, so from 00, let's start out here with the first usable IP, 127.0.0.1, and it's going to go all the way up to 127.255.255.254, and so that would be the usable range. And the question is, why, what exactly is it that the loopback address does? Well, the loopback address in and of itself does not have connectivity out to any other networks, and the reason for that kind of goes back here. We'll draw it out real quickly, and I'll use the OSI model as a reference here. So you've got layer 7, which is your application layer. Layer 6 is the presentation layer. You've got 5 is your session layer. And then you get down to 4 is the transport layer. And we're really interested in layer 3, which is our network layer. And then we've got layer 2, which is our data link. And then layer 1, which is awfully big here, which is just our physical layer. And so the way loopback addresses work is when you reference, or let's say if I ping the loopback address, the internally in the Linux system, it's going to come down, it's going to reach the OSI layer 3, the network layer, and then it's simply going to loop back. And so that's really where the name came from, is it's going to come all the way down to the network layer, and then it's going to turn around and it's going to loop right back. Right? So it never gets to the data link layer, and it never gets to the physical layer. So in effect, it's kind of cutting out the physical and data link layers from the testing, right? And so what exactly is it that we're testing with a loopback? Well, typically you're testing your TCP IP stack that is local to the host, right? And I remember back in the early 90s when we would have network issues, the first thing they would ask us to do is they would say, well, hey, you need to ping the local host address on your Sun system to see if the TCP IP stack locally may be corrupt, and then work your way out from there. And so that's really one of the uses of the loopback address, probably one of the most popular, is to simply test the internal TCP IP stack. And so we're going to create a container, and we'll talk about some use cases. When I first saw this container type, it took me a while to think of some valid use cases for it. But I've got a couple that may or may not be applicable to your environment. But again, it's a great way to create a Linux container that is literally 100% isolated from a network perspective from anything and everything else that might be out there. And in fact, we're going to create this empty container on the same Ubuntu virtual machine where we have all of the virtual Ethernet adapter types that we created yesterday, right? So we've got a custom bridge set up. We're also using the Linux container bridge, LXC BR0, and so all of these containers are going to be running concurrently, including our empty container type. All right, so let's go ahead and jump in here. I'm going to clear the screen, and we'll come back over here to the main window. We'll get logged in, and you can see that we have the container types, virtual adapters for the container, the virtual adapter types for the Linux containers that we had created throughout this series. We've got our 5 basically default virtual Ethernet adapters that we created, and then we created a custom bridge interface, BR0, to which we linked 2 more Linux containers, one of which is running here at the top, and the other one is stopped. So let's go ahead and spin up some new, so we'll say LXC create Linux containers, and the virtual adapter type is going to be empty. So the only address that you're going to see on these adapter types is literally the loopback address, and we'll take a look at that here in a second. So we'll say LXC create -n. So what's our name going to be? Well, we'll keep our same naming convention. I'll say ubu empty 001, and we'll just use the Ubuntu template. And again, remember that the subsequent container creations are always going to be quicker than the initial one, because we've already downloaded into the var cache LXC, and that vivid there is represents the release, the root file system, rootfs-amd64. So instead of having to pull all that information back down, all it's going to do is copy the information over to our new empty container. And remember that by default, the Ubuntu template is going to set the virtual adapter type for the container to be the virtual Ethernet adapter type, and it's going to be dependent on that DNS mask process running on the Linux bridge, the LXC BR0 bridge, to get its DHCP addressing information, as well as providing the DNS resolution. Or I should say, it doesn't really do the DNS resolution, it forwards it along to a legitimate DNS server. All right, so our container has been created, so LXC-ls-fancy. Let's take a look at what we've got here. And so you can see we now have our Ubuntu empty virtual adapter, Ethernet adapter type for that container. However, remember, we're going to have to go down into var lib LXC, and this is going to be ubu-emp, and if I type ll, you can see there's my root file system along with the config file, and this is the default config file. So let's copy it over. So we'll say copy config to config.orig.tpbonfee.07112015, and let's vi config. So we should be familiar with this file at this point, right? We took a look at a series of network types for the virtual Ethernet adapter. So this one is simply going to be empty. And so an empty network type, I could actually leave this line in here, and it is not going to link to that LXC BR0 bridge, right? So there's no harm in removing that line. We want to make sure the interface comes up, and we'll go ahead and leave it with the MAC address that it was assigned upon its creation. So all I'm going to do now is save that config file, and now it's time to actually, and let's see, take a look here so you can see that it's stopped, right? So we're looking at this container here, ubu emp 001, and so now let's start that container up. So I'm going to say lxc-start-n ubu-emp-001, and this is going to start up rather quickly. I'll clear the screen, and let's take a look at the output. So now, what do you see immediately that's different here? from the other containers that are running on this virtual machine? Well, the first thing that's striking is that it has no IP address, right? So for the IPv4 address, it doesn't show anything. And this is to be expected, right? Because again, we've chosen the adapter type of empty, which means no IPv4 address. It's only going to have the loopback address. So let's go ahead and console over and take a look at the actual container itself. So ubu-emp-001. So we'll log in with Ubuntu and Ubuntu. All right, so here we are. We're on our container with the adapter type of empty. So if I were to say if config, and you can also use what is it, IP, I'm trying to remember, there's an IP command, something list. IP, is it interface list or IP show? Give me a second here, I'm thinking. I don't usually use the IP command too often. IP something list, address list. There you go. You could also use IP address list if you wanted to, and you'd be able to see that information as well. So here we can see that the only interface that is on this system is the loopback interface. So let's check and see. So from this container, can I ping the host address, which is 192.168.1.119? No, the network's unreachable. How about the internet? Can I get to something on the internet? Absolutely not. So I have no IP addressing other than the loopback address. So again, what's going to happen, because I only have the loopback address, right? So 7654321. So 765, put these down. This is the OSI model here again. So when this system is doing anything network related, right, or if I'm pinging the address, the loopback address, it's going to hit layer 3, which is the network layer, and it's going to loop it right back, right? So it'll never get to layer 2, it'll never get to layer 1, and I'll scratch it out. It'll never get to layer 2, the data link layer. It'll never get to the physical layer. So the traffic internally is going to come down to layer 3 in the kernel, and it's going to loop it right back to the system itself, right? And so that's why all of these attempts to connect or to establish reachability with any of the networks that are not on the local host are not going to work. And let's take a look now at that etc hosts file. So what do we have here? So as you can see, we only have, for IPv4, we've got our local host address, and then here, and this is interesting, remember that this was the address that the DNS mask process was listening to when we used the default setup with the virtual Ethernet adapters. And now that address has actually been assigned to the host itself, right? So you've got the local host address, and then you also have the 127.0.1.1 address being assigned to the host in the host file. And then we have our IPv6 loopback local host information here as well. So can I ping myself, right? So what if I said ubu-emp-001? Absolutely, I can ping that address, which is in the loopback range. What if I were to just simply ping localhost, which is 127.0.0.1? And it works. However, I can't get connectivity to anything else on the network. I can't connect to the host from the container. I can't connect to another host on the local area segment to which the container is the virtual machine is connected, and I certainly can't get out to the internet. So then this kind of brings up one of the questions, which is, okay, well, that's great that we've got this empty container type, but why in the world would I want to create, not empty container type, but empty adapter type for within the container? And it brings up the question, well, what's the use case? I mean, why would I want to use the virtual adapter type of empty inside my container what purpose would that solve? And so, there's a couple of use cases that I thought of that popped into my head. And the first one is within an academic environment. Let's say that you have students who are trying to learn the Linux operating system, and you don't want to give them access to the network. So it would almost be like sort of a change root scenario, but they would have their own Linux container. So if that was what I wanted to do, let's say that on this container right here, this empty adapter type container, if I were to say group add -g, we'll just use 1, 2, 3, 4, 5. I'm just basically creating a group here, and we'll call it students. And actually, I'm going to have to sudo to the super user here real quick. So Ubuntu and group add -g 1, 2, 3, 4, 5 students, right? And then if this container was going to be for student 001, whoever that may be, I could throw the user add command in here. So let's create that user account, and the group that they're in is the students group, and we'll just give them 9000 as their unique identifier. Home directory is going to be in /home, and password we'll just say abc123 for right now. Create that create that home directory for us, and who's the student? So student 001, right? So now if I cat etc password out, you can see down there at the bottom we've got a new account for student 001. So then I could basically, as long as the student, what we're saying here is that this virtual machine, right, that we've started in VMware, which is Ubu 003, and maybe this is for your shell scripting class, maybe it's for an introductory Linux class, excuse me. We go ahead then, the students can SSH to the main virtual machine, and then each student could then do the LXC console command and connect to their Linux container. And then it's in that container where they can go ahead and write shell scripts or do whatever. Upon initial creation, you could even clone it, or you could snapshot it, so that if for whatever reason the student called up, opened a help ticket and said, hey, I did an rm-rf star from the root directory, I'm having issues, you could then restore the clone, or restore the snapshot, or fire the clone up for them, or whatever. But that's certainly one use case. Now again, they're going to be isolated because they can't connect to anything on the network, but that might not be such a bad thing. So academic environment would be one use case. Another use case could be if you're trying to do some sort of application testing maybe, and you want to isolate that testing so that it has no network connectivity. You could use the empty adapter type within your Linux container. And then the final one that I thought of, and again, I haven't given it much thought because we don't use, or I don't use the empty container type a whole lot, empty adapter type within the container a whole lot. But what makes sense, maybe you've got a new employee or someone who wants to learn about Linux, right? And what you could do is, instead of putting them on a production machine to mess around, you could create a container for them, right? Just create an empty container type for them, and whoops, sorry, where are we at here? I'm going to say, just create an empty container type for them, and maybe the employee's name is Bob, right? So we can go ahead and immediately, within a matter of seconds, fire up a Linux container that will go ahead and change and make the adapter type empty, and then Bob maybe SSHs into the host machine, which is our VMware Ubuntu host here, and then he can just simply LXC console to his Linux container, and then get in there and kind of mess around and practice basic commands like ls, who, uptime, cat, copy, remove, whatever, right? But again, he's doing it in an environment where he can't cause any damage because he doesn't really have access out to anything else in the environment. So let's take one last look here. And here we go. So this could be Bob's empty virtual adapter type Linux container that we're going to allow him to go ahead, start up and stop and do whatever he needs to do, right, without impacting the rest of the environment. And you could even go so far as to maybe do control group, C group work to limit the resources that he's able to monopolize or use with inside his container. All right, so again, this one's pretty quick, right? As you could see, not a whole lot to be said about the empty virtual Ethernet adapter type with inside the Linux container. So that kind of wraps up this video. Again, use cases are pretty limited, but the adapter type does exist, and so I wanted to make sure that I covered it, as well as showing you how to go ahead and create it. And remember, for the one that I just spun up here for Bob, you would still have to go into var LXC, I'm sorry, var lib, LXC, and this is ubu-emp-bob/config. And remember, I'm not going to make a copy of it here, so we're going to change this and say empty. It's not going to link to the bridge, and we'll just bring it up. And there we go. And so then Bob can come in at his leisure and start his his ubu-emp-bob Linux container. All right. And so that's it. That wraps up the empty container type. Thanks for watching, and enjoy the rest of your weekend.